Imagine a world where the energy crisis is a distant memory, where sustainable solutions power our daily lives and the transportation industry. Sounds like a dream, right? But what if it's closer to reality than we think? Today, we're diving into the world of hydrogen and ammonia as alternative energy sources. We'll look at how these two elements, abundant in our universe, can revolutionize our energy consumption patterns and fuel various modes of transportation, from commercial vehicles to light and small vehicles, aircrafts, and even sea transportation. Hydrogen and ammonia are not new to the energy scene. They've been used for decades in various applications, but their use as fuel has gained significant attention recently, and for a good reason. Let's take a case study. A commercial trucking company, which recently switched its fleet from diesel to hydrogen fuel cells. The company reported a significant drop in fuel costs, improved energy efficiency, and a drastic reduction in emissions. The energy density of hydrogen fuel cells allowed their trucks to travel long distances without frequent refueling stops, improving their operational efficiency. Another case study involves the shipping industry. A sea transport company chose to replace its fossil fuel-based systems with ammonia combustion engines. The result? A dramatic decrease in harmful emissions and an increase in fuel efficiency. The high energy density of ammonia, combined with its ease of storage and transport, made it an ideal choice for maritime transportation. These examples are just the tip of the iceberg. Hydrogen and ammonia hold immense potential as sustainable and efficient energy sources. They can be used in combustion engines, fuel cell propulsion systems, and even as backup power generators. Their advantages are clear. They offer high energy density, safety, cost-effectiveness, and utility across various modes of transportation. But what about their environmental impact? When produced through Trident Energy Systems' high-efficiency, high-pressure electrolysis technologies, hydrogen and ammonia can be generated from water and air. This process significantly reduces the environmental footprint compared to traditional fossil fuels. In conclusion, hydrogen and ammonia are more than capable of addressing the current energy crisis. They offer sustainable solutions that can power our world and transform the transportation industry. The future of energy is here, and it's cleaner, more efficient, and more sustainable than ever before. So isn't it time we embrace these energy sources for a better, cleaner, and more sustainable future? Another aspect that sets ammonia apart from other alternative energy sources is its production flexibility. Believe it or not, ammonia can be produced from virtually any primary energy source. This includes wind, solar, biomass, coal, nuclear, hydro, and even ocean thermal energy. The only other fuel that can make this claim is hydrogen. This wide-ranging flexibility in production makes ammonia not just a versatile choice, but a truly sustainable energy source for our future. When it comes to environmental performance, NH3 ammonia fuel stands out as a truly green alternative. Notably, NH3 ammonia fuel is environmentally friendly, producing zero carbon dioxide and low overall emissions. The only significant pollutant emitted by either hydrogen or NH3 is nitrous oxide. Interestingly, gasoline and diesel exhaust also contains nitrous oxide, and NH3 is commonly used to reduce these emissions. With an onboard supply of NH3 fuel, it will be even easier and more cost-effective to use NH3 to react with nitrous oxide over a low-cost catalyst and produce environmentally benign N2 and H2O. In conclusion, NH3 ammonia fuel not only provides a sustainable energy solution, but also helps in reducing harmful emissions, making it a win-win for our environment. In terms of flexibility and availability, ammonia fuel, or NH3, takes the lead. Its ability to be utilized in any prime mover, be it diesel engines, fuel cells, spark ignition engines, or gas turbines, is an enormous advantage. This versatility opens doors to various applications across industries. Now let's talk about availability. On an annual basis, the United States has approximately 15 to 20 million tons of liquid ammonia in distribution networks. Historically, this NH3 ammonia was primarily used as a fertilizer and commercial refrigerant. But imagine if we could tap into this existing network for fuel. Several states, including Iowa, already have an extensive filling station network. which could be easily adapted to supply NH3 fuel to farm machinery and eventually highway vehicles. Implementing such an NH3 fuel delivery network would be considerably more straightforward compared to, say, hydrogen. Therefore, not only does ammonia fuel provide a sustainable energy solution, but it also boasts an existing infrastructure that could be leveraged for its distribution. This is a significant advantage in accelerating the transition towards greener energy sources. Moving on, let's address the elephant in the room: safety concerns associated with ammonia fuel. First and foremost, it's important to note that ammonia has an extensive, proven record of acceptably safe use. Two very credible studies suggest that NH3 is safer than propane and as safe as gasoline when used as a transportation fuel. However, there are many misconceptions surrounding the safety of NH3, and providing factual data on this topic is a key goal of Trident Energy Systems. Are some facts you should know. NH3 is a weak base and can be easily neutralized with weak acids such as citric and acetic acids. Compared to gasoline, propane, and natural gas, NH3 has a much better safety record, including fewer loss of lives. Upon combustion, NH3 releases zero carbon, resulting in no greenhouse gases. The nitrogen oxides produced are easily neutralized. Interestingly, NH3 is used as the active chemical reactant in NOx reduction and CO2 and SO2 capture. In case of an accident, NH3 is very difficult to ignite. It is lighter than air and thus dissipates upwards, and its strong odor serves as an alert. 1. NH3 is not a greenhouse gas and won't damage the ozone layer. Not only is ammonia fuel a sustainable energy solution, but it also boasts a proven safety record, making it a viable alternative to traditional fuels. Let's break the misconceptions and embrace the future of energy.